Hello and welcome, this is Ellie Rathbone. Welcome to a new entry in our GTK4/GObject tutorial series in which we'll discuss two things. One being how do we start a GTK4 project hierarchy with GNOME Builder, which I've got right here, and two, templates in GTK4. Now mostly the first piece of what we're doing is really tangential to what we're actually trying to accomplish, which is discussing templates. But I thought it would be a good opportunity to also show GNOME Builder a little bit, which is a tremendous program. And I'm not going to actually really be using it to edit the source code very much, but it's extremely useful, as you see, and I do this on a regular basis to set up the boilerplate code for a project that uses the Meson build system. And so instead of messing around with make files as we've done in the past for these small demo-y projects, we're going to show how you might actually create a real quote-unquote project that's a little more scalable. We're going to keep it very simple today, but we're going to at least start that conversation. So firstly, I'm going to just go to my preferences for a second, and I'm going to show you a couple of changes that I'm making to the defaults. If I go to here and then C for the languages, this will allow me to see, here we go, source C. This will allow certain formatting preferences to be set within GNOME Builder. And you'll probably find that your settings are a bit different than this, but I prefer tabs over spaces. I may change my mind on that at some point, but I'm still, by force of habit, prefer them. I like four spaces for a tab, and I want the indentation number of characters to match the tab size, so I'm going to put that as -1. And I don't really know what this whole trailing new line business is about. I don't personally see the need for a trailing new line, so I'm going to keep that off, or turn that off rather. I think it was on by default. I wouldn't really lose much sleep over whether that's on or off, and I think that I have kept everything else the same as the defaults. But if you want to match what I'm doing, there you go. And because I'll also be using code that was generated from my regular script that generates GObject boilerplate code for the customized widget that we'll be discussing, I want it to match those settings that I use for that, as opposed to having a mix of tabs and spaces. So we're going to do that. We're going to create a new project, I should say. What's it called? It's going to be called Demo. The application ID, we're gonna use com.example.demo, and it's good to have the last piece capitalized, like using, what do you call it, camel case? I forget what it's called, but it's kind of idiomatic to have the first letter capitalized in any event. It's going to go into the projects folder / directory. It's going to be the C language and all that jazz. I'm not going to worry too much about this, but I'm going to change it from GNOME application to GTK4 application. So it's not going to use libidwadia. It's going to just use GTK4. But you could certainly choose to use a GNOME application if you like. Create project. Okay. So what that's going to go ahead and do, we're not going to update this SDK right now. It's going to create a whole whack of boilerplate code that we will use the Meson build system. And as you see, all this stuff here that is generated, we don't have to write ourselves, which is pretty nice. What it's actually gone ahead and done is it's created its whole own application class, its whole own window class that are named after our project, which is Demo. We're not going to worry too much about that. We're going to focus on a customized widget that we create that uses templates, but just so you know, that's what it has done. And so now that it's created this code, we're actually going to quit GNOME Builder for now. And if you see here, I've got a backup that it's going to have the customized widget files that I do want to use in a few moments. But for now, let's go to the demo folder that's been created by GNOME Builder. And I'm going to do a quick thing that you will not have to do in your system, but I'm going to export my LD library path. And I'm only doing this because I have two versions of GTK installed. You should not be doing this. And if anybody that knows anything about LD library path is watching this now, you're probably dying a bit inside. So just You guys don't do that. I'm just doing that because I've got 2 versions of GTK installed, and it's going to get messy if I don't do that. So forget about that. And then Meson, setup, and then the folder that you want it to use for its internal machinery. We're going to call it build. It's going to go ahead and do all this stuff. It's kind of like the /configure of the old days. And then we're going to do ninja-c, capital Z, build. And this is like the same as make in the old days. So ninja-capital C, build, enter. All right, took 2 seconds, it's built. And now we're going to do something that Christian Hergert would kill me if you saw me doing, but we're going to run this project in tree. We're not going to install it to the system. We're just going to run it right from within the project folder. So to do that, we run build /circ/demo, enter. So we've got this program here, and it's called demo, as you see. And you see it's not just a classical window with nothing in it like we've seen in the past with some of our little demos that we've done. It's created a whole application window with a menu, an about screen, a keyboard shortcut window, etc., etc. Everything's nicely laid out. But what it has is, I believe, as its only child, a GTK label that has the label Hello World. So what we want to do is yank out that label and replace it with a customized widget that we call demo widget. And what's demo widget going to be? Well, let's go ahead and just show you what we want the final product to be. Let's go out of here and go into demo.back. I believe it's already built, so let's just go build. If I could type circ demo, enter. So instead of instead of the default, which is a label that says hello world, we're going to create something called, if I open in the inspector, Control-Shift-I, a customized widget called demo widget. And if I double click there, this whole thing is flashing because this please enter your name plus this entry, all that mushed together is considered the demo widget. So this is considered what's called a composite widget because we are taking pre-existing widgets that are either baked into GTK or other customized widgets that we've created or somebody else has created and mushing them together to make a widget that is made up of the components of those other widgets. And that's why we call it a composite widget. And those are very common, and they're very commonly built using templates. So we're going to show what those concepts are all about. So if we run something here called GTK4 widget factory, if you're thinking, well, where can I kind of find these widgets to pull from and mush together? Well, this is one place you could look. It's called the GTK4 widget factory. And it's got almost every widget that GTK has to offer, and they're all mushed together in one tabbed app, so you can sort of see what all the widgets are on display. And if we do Control-Shift-I to pull up the inspector, it's going to show us, if we click on this crosshair, we can then go ahead and choose any of the guys here, and it'll tell us what we're working with. So for example, this one looks kind of interesting. If I click, it's hard to see that's being highlighted, but it is. It's going to tell us that this is a GTK picture that's actually playing a video, and it's called video. The idea of it is video underscore picture. So if you wanted to say, for example, put a little video in your composite widget, you could then say, okay, pull up the inspector, highlight the widget, find out what it is. Okay, that's GTK pictures. That's what I want to utilize. And then that's a good way to get a sense of what objects are that you like to mush together to create a composite widget. But we're going to make a really simple one with the label and the entry. That's it. It's not going to do anything. They're just going to exist. That's it. Just to show you the very bare bone basics of how to create a composite widget. So if we let's do 2 things. Let's take a look at what's in the circ here. We've got demo-widget.c, demo-widget.h, and demo-widget.ui. And those are, I'll just take my word for it, the 3 files that you're not going to see in the demo folder that GNOME Builder created for us. So what we're going to go ahead and do is we're going to go back to our demo, and let's go to the circ folder. Let's copy the backup, everything demo widget oriented, demo widget.star. Let's just copy it all in here. Great, it's all here. Now let's take a look at the UI file, the H file, and the C file for the demo widget. We're not going to worry too much right now about what the other files have in them, except to the extent that we need to integrate our customized widget into that application, right? And you can certainly, as an exercise in your own time, look and do a deeper dive into what the code actually is in the other files. Not a problem. So let's open up demo widget.c. Let's make a new vertical split and open up demo widget.h. Let's make that a bit, whoops, oh my goodness. Bear with me, I closed that by mistake. I've never really done that before in my life, but just did it now. Make it a bit smaller, Control W, 15, and then the less than sign to make it 15 characters smaller. There we've got the C file, the H file side by side. Open a new tab. Let's look at the demo widget.ui file. And let's start with this guy. So to create a template widget, which will again just be a composite widget just showing the label and an entry mushed together, what we do is we open the interface tag as per usual, but instead of saying object class is equal to something or other, we say template class is equal to, and make sure you pick the name of the widget that you want to be called, and make sure that you specify what the parent type of the customized widget will be. And we just want it to derive directly from GTK widgets. So that's what we're going to go ahead and do. As opposed to in code using GTK widget class set layout manager type, we're going a bit of a mouthful. We're going to just open up a property tag and set the layout manager property of the widget. And if you take a look, let's go to GTK widget here in the documentation. The properties are shown somewhere down here. There we go. There's a lot of properties for GTK widget because it's a big class, and one of them is layout manager. So that property that we're setting is a GTK widget property. So we're going to go ahead and do that there, and we're going to just directly define that layout manager to be one of type GTK box layout, which will allow our customized widget to work like a GTK box, which I believe we've discussed before. The orientation of it is going to be vertical, and there's going to be 6 pixels between each component, right? So that's how we're going to do that. And then now that allows us to just use the child tag to just create 2 guys as children to our widget, demo widget, which will be almost as if our own customized demo widget was a box container, GTK box container, right? So first child is going to be a label. It's going to be the name. It's a bit confusing because the property name of the GTK label is also label, but it's the text of the label is going to be please enter your name. The name of the object class is the name of the object instance rather. The ID will be label, and make a mental note of what these IDs are, because unlike other times that we've used the GTK Builder API, the ID does matter in this case because it's going to be directly utilized by the template API. So make sure that you make a mental note of what you're actually calling these widgets that are part of the composite template. So GTK label, and then we're just going to make a plain vanilla GTK entry with no customized properties set whatsoever, and we're going to call it ID entry. Okay, so let's go ahead now and let's look at the H file first, because it's almost completely boilerplate for a final type that we've discussed before. We've used gdeclare final type, and this name, whoops, oh my goodness, whoops, oh my goodness. Okay, here we go. this name demo widget here has to match up with what you've called it in the UE file. I mean, it sounds straightforward, but you can't just call it whatever you like. You do have to use the same name because we're using, the API for GTK Builder is using its own network of macros, functions, and all these things that make those assumptions. So make sure that, again, the type that you're deriving from is specified here. Make sure that's consistent with both the UE file and your gdefined type line, which is in your C file, which we'll come to in a moment. And then the constructor is completely boilerplate. gbegin decals, gn decals, completely boilerplate as per usual. So the struct for the final type is created in the usual way. Now here's where we diverge a bit. We want to be able to access the label and entry widgets as struct members, and this is where the template mechanism makes it very convenient. So we're going to make two template children of type GTK widget that are called label and entry, and they do have to match up. That's why I was saying before, be aware of what you name them. They do have to match up with what you name them in the UE file in terms of the IDs. Fine. So keep a mental note of that for a minute from now. gDefine type, again, we already talked about that. The init function, here's where we put some template mechanisms in place. So according to the manual, you should typically run this function. Oh my gosh, I keep typing the wrong things today. GTK widget init template as the first item in your instance init function. So we're going to go ahead and do that. It doesn't take any arguments, but the instance which we have to cast to GTK widget, but nothing too interesting going on there. If you wanted to do other things like setting up a gesture, setting up actions, whatever the case may be, you should probably do that below the init template line, for instance. Now the dispose function, there's the newer way of doing it and the older way of doing it. So if you're targeting, I should say, GTK 4.8 and higher, then you can use this newer function called GTK widget dispose template, and it will do all the work for you to unparent anything that needs to be unparented, which is very convenient, but you do have to be using GTK 4.8 and higher to use it. All you do is pass the instance, which is our self, cast to a GTK widget, and the type of our own customized widget, which is demo type widget, right? So you do need to pass that as a second parameter, but it should be fairly easy to set that up. The older way of doing it is you need to sort of be aware of who your direct children are. So we know in this case that our two direct children are label and entry. And they're going to be set as children using the template machinery. We need to unparent those guys ourselves. So that's why the older way of doing it is that we use the gclear pointer function along with GTK widget unparent, as we've done before, to unparent those guys manually. If these guys had their own children, you would not have to manually unparent all of those children, because that would be done. That would be done at the time anyway of unparenting those particular widgets from our main guy. So you wouldn't have to do that manually. Only direct children need to be unparented. And so, in fact, if you're sort of thinking ahead a little bit, you might have realized that we didn't really even need to create these struct members, even though you might think later on it might be useful to do it if you want to utilize them in code. We didn't really need to even create those, except that for these two lines of code, we do need to access those struct members and to unparent them, and so we do need to create them as struct members. But because we're not doing anything in this instance, we're not setting them up in any way, we're not adding signals to them or doing anything special, technically we didn't need to do that if we were set them up as struct members if we were using dispose template. But if we didn't set them up as struct members, then in this demo, then you wouldn't know how to set up struct members using the template machinery. So we're gonna do it that way in this example anyway. So And then if we scroll down, finalize, we've done nothing. It's completely boilerplate. The class init function, we have our typical dispose finalize being set up here. But then, here's how we actually set up the template machinery in the class init function. You've got to call GTK widget class set template from resource, and then you pass the widget class, which we set up here, and you pass the resource path. Now, where is the resource path coming from? You might think, well, why can't I just tell it? Because this is obviously not a file path. This is what's called a resource path, which is almost like a fake file path that uses the application ID components in order to sort of get you there. Like it's not, home/user/circ/demowidget.ue or anything like that. It's a resource path. Where does the resource path come from? Well, this is something that was very helpfully set up by, where is it here? The GNOME Builder application. Sorry, it's hard for me sometimes to talk and code at the same time. So you see here, it has set up our resource prefix here. The dots of the com.example.demo are typically replaced with slashes in order to craft a resource prefix. And you'll notice, if you're paying great attention, that when GNOME Builder created this template, it knew nothing about demo widgets, so it's not included the demo widget.ue file in here. So while we're here, why don't we go ahead and add it? So just copy this line and paste it here, and then we're just going to replace demo window with demo widget.ue. And so now, when we build the code with Ninja, it will know to look for this demo widget.ue guy, and it will allow us to access it as a resource using this path, right? So that will allow us to access that now that we've added it to the resource XML file. And then, in order to actually be able to utilize the struct members, we need to call this function macro called GTK widget class bind template child. And what it does is it takes widget class, which we've again defined up there. It takes the name of the class type, so demo widget, and then it wants a token, which is label and entry, as you see here. This stuff up to these last parameters are all the same, which are used for multiple purposes. So it's used not only as a string to grab the ID from the UE file, it's also used as knowing where to plop it into the struct members. This is why all of these tokens have to match up with each other. If they don't, it won't work. You get some really bizarre errors coming up on the screen, so just make sure that you pay attention. And so these calls here will subsequently allow us to just go self-arrow label and self-arrow entry to be able to grab those guys. So again, this is part of what setting up the template machinery makes things a lot more convenient for us. So then we've got our constructor public function, which is boilerplate, completely the same as always. So that all looks okay. So now how do we go ahead and actually plug in our demo widget as opposed to the label that they have in the demo that was created by GNOME Builder? Well, let's see. Let's see what we have here. Let's actually just go in here. It might be easier to see. So we've got, what UE files do we have? We've got demo window.ue, and that gives us a pretty good hint as to what we might want to look at. So let's take a look at demo window.ue, and this is something that GNOME Builder created for us. So if we go ahead and look here at where GNOME Builder has put this demo label for its purposes, it's created, and it's actually using a template as well to create our demo window. And it's setting the child property of the window, which will mean that the window will just have one child, which windows can only ever have one child. And it set that child to be a GTK label. So instead of setting that up to be a GTK label, we're going to set up to be a demo widget. And the ID, let's make the ID demo. And I don't believe our object really has any interesting properties. Oh my gosh. This is where Vim sometimes. How about that? Okay. Should work. And then where's the closing tag here? Here. And that should work. Doesn't have any interesting properties, so we will just leave it at that. Property child is equal to, property name is equal to child. And then we just tell it that we want it to be a demo widget, and the ID will be demo. So obviously that's not going to be enough. Let's use our knowledge that we just gained about templates to then go ahead and look at the demo window.c file. So they've got their label here. Let's just go ahead and replace that with demo. And Christian Hergert likes to use the name of the actual widget. I prefer to just keep them all as GTK widgets. That's a more older school way of doing things. That should be fine. Now if I search for label, here you see they got their class init function where they have asked to bind the template child to label. So let's go ahead and replace that with demo. What we may need to do, I don't know if this is necessary, but I don't believe it can hurt. And if I just look at my old, at the backup to recall where I did it before, if I grep for g type ensure, where did I put it? Okay, yeah, that's fine, I guess. Might also make sense to put it, oh, I see, I put it in demo application init. That's probably fine. I think there's multiple options of where you could put this call. I just want to make sure that the machinery is aware that it needs to look for a customized widget. Seems to me like it might make more sense to have it here. Let's see if this works. Let's go g type ensure demo type widget. Oh my goodness. There. And then we'll load this resource right here for the demo window. And somewhere along the lines, we're going to need to include the demo widget.h file. Let's just do it right here. Demo widget, because it's not going to know anything about, it's not going to know where demo type widget comes from unless we include that header. I think that should work. I'm kind of flying a bit by the seat of my pants here, but let's just see. We already got the demo window. We got the demo window there. We replaced label with demo. Again, I don't know that we even really need to. Sorry, I'm losing my train of thought. I don't know that we even really need to create this this struct member, but it was there before. Let's keep it in there. Anything else we need to do? I don't know. Let's see. Let's go into. We've already got that. All right. Anyway, I've got too many tabs open now on my terminal. I'm confusing myself. Let's go. Let's just delete the whole build directory and start it from scratch. Do I have my LD library path set? No, I don't. Okay. I have it here. All right, let's clean up this mess that we've left for ourselves here. Yeah, this is the backup. Hopefully I actually modified files where I was supposed to and not in the backup folder. Okay, widget.ui is there. Let's see, the demo window. Got the demo there. I think it should be okay. All right, we deleted the build folder. Let's create it again. Meson, setup, build. All right, ninja-c build. We got an error. Okay, so we got a linker error because it doesn't know where to find demo widget get type. So what that means is we're missing, again, the make file where we would add an object file to link, right, to the binary. So the way that you do that in Meson is you edit the meson.build file, and your source is here, and this is in the circ folder, just to be clear. The meson.build file in the root folder has more generalized settings. This is more where we include the source files. We have to go ahead and include the demo widget.c file right here. And so that should now tell it to add it as an object file to build the binary. So let's, you know what, let's just start. Let's go ninja-build clean for it to just get rid of everything, right, rather than deleting the directory. And let's go meson-c build. It looks like we built it. And now, if we run, let's see, if we run build circ demo, it should, here we go. So we've got our application window, and you see now we've got our customized widget, demo widget here, which is simply a composite widget made up of the label and the entry. So this should hopefully give you a baseline as to how, to understand how templates are created. They're used very commonly. It should also give you a base idea of how to create a more scalable type of a project, and you can always initialize that. You can do it manually if you want, but with GNOME Builder, it does make it a lot easier to initialize some of that boilerplate code. And we've created, again, if we just double check in the inspector, get this guy highlighted, it's demo widget. It's not just showing, right, two children of the window as being like a GTK box, for example, with a label and an entry. It knows now about our customized widget called the demo widget. So that should give you an idea. Hopefully that helps. Any questions, post them in the comments. I'll probably make another video soon expanding on something that we've discussed. I might do another video on expanding on the discussion of GTK list view and column view pretty soon, because I think there's a lot more ground to cover that we have there. And I think I'll also just sort of build upon this video a little bit, make a part 2, and talk about how to like continue building an application using composite widgets. So there you have it. Hopefully that helps. This is Elliot Rathbone signing off. Good night and good luck.